In the next few examples, we want to revisit some of those factoring techniques we've already been looking at, but add one additional step where we begin by factoring out a greatest common factor. This is always a great first step to consider before factoring or before beginning the factoring process, is first see, is there a number that divides evenly into each term? In this case, 4 divides evenly into all 3 terms, so we could rewrite this as 4 times the quantity x squared plus 2x minus 15. Factoring out that greatest common factor of 4 has simplified now the polynomial that we want to factor. We no longer have a leading coefficient that's different than 1, so we have a simpler case to consider. In this case, we could go ahead and factor this as x plus 5 times x minus 3, because 5 times negative 5 would give us, or 5 times negative 3 would give us negative 15, and 5 minus 3 would give us the positive 2 that we're after. In example 12, every term in this case isn't divisible by a number, but is divisible by y squared, meaning we can begin by factoring out y squared as that greatest common factor, which will leave us with the quantity y squared plus 10y plus 21. Initially we had something that started off with y to the 4th. Now this factor with that greatest common factor pulled out, or this expression, begins with y squared. So we can apply a simple factoring technique to rewrite this as y squared times the quantity y plus 7 times the quantity y plus 3. In example 13, we only have 2 terms, both of which are divisible by x to the 7th. So if we start off by factoring out x to the 7th, we're left with x cubed minus 1, which is the difference of cubes. So we can factor this as x to the 7th power times x minus 1 times x squared plus 1 times x, or just x, and then plus 1 squared, which would just be 1. Again, every time you start off a factoring problem, a great first step is first look to see if there is a greatest common factor. If there is, pulling that out, factoring it out in front, will leave you with a simpler problem to then apply our factoring techniques to.